Hello friend, welcome to Gokul. Today we will see eigenvalues and eigenvector. So what is eigenvalues and what is eigenvector? Eigen meaning spacer, value means scalar. Here value means scalar. So eigen you have seen. So vector having magnitude and direction. Right. So before going into the eigenvalues and eigenvector detail, let us see what matrix does. So you have a matrix and you have a vector. So you are giving vector into a matrix and it is omitting a other vector. It is omitting other vector. Right. Like, so if you have vector x, so if you have vector x and matrix A, it is going to give you a x. It is going to give you a x. Right. It is exactly similar what you have studied in calculus. Like if you have a function f, right, you are giving a value a, it will omit a function fa. Okay, so this is about the eigen. So this is about the matrix. Let us see one example. You have a matrix 0 1 1 0, right, and you have a vector say 1 0. You are giving this vector into a matrix, it will omit what? 0 1. Right. You can see by example here, by graph, this value read 1 is indicated 1 0. This is input. If you have this input, this is input, and the green one, this green one is your output. Right. Let us more generalize it by saying that, say, let us more generalize it by taking a generalized vector which depends on value theta. Say you have a vector r cos theta, r sin theta, and you are giving in a matrix 0 1 1 0. So what it does, it's doing r dash sin theta, theta dash r dash cos theta dash, right? So here, if we will compare to the previous one, like theta equal to 0, and here you have theta equal to 0 degree. So if we will take the another example, say theta equal to 45 degree, then here will be 1 1. If we will give you 1 1 in 0 1 1 0, then it will omit 1 1, right? So one more example I will see at theta is equal to 30 degree. So you will giving 30 degree means root 3 by 2 1 by 2, giving it 0 1 1 0. It will omit 1 by 2 root 3 by 2. Right. So let us see this thing by a graphical method. So here is your red one. Red one is your input and green one is your output. So this is theta is equal to 0. So if you are giving theta is equal to 0, so it's omitting the vector 90 degree perpendicular to the input vector. So if you are giving say theta is equal to 30 degree like this, so theta is equal to 30 degree, so it is omitting somehow like green one. So like it is approaching towards a 45 degree both of the input and output. So it's continue. Once you will give it so 1 1, so it will omit 1 1. So here is your case. So going forward, you can see whatever the red is like input and green one is your output. You can easily see when you are giving a vector into a matrix how this output, the red one is your output, how it is, sorry, the green one is your output, how it is changing. Let us see one again. So from starting, so it will be a clear everything to you. See, red one we have given a red one is your input, green one is your output. Okay, moving forward, so we have understood the what matrix does. Now we will see what is eigenvalue. Okay, the definition like whatever you have a matrix and you are giving a vector x and it is coming a vector ax. So if x parallel to ax, then the vector x is called eigenvector. Right. Let us take a previous example. That previous example was there. Matrix was there 0 1 1 0. Let us take the same example and we will give it a vector say 1 1. Right. It will omit 1 1. Right. So let us see how it's working. So you are in giving a vector and so this is so when it is so you see at angle is equal to 45, the whatever the input is there, so it is coming output, right? So theta equal to 45, right? So at this theta is equal to 45, so yes, this is coming parallel, so this one will be your eigenvector. Let us give more vector to it and let us see. So red one is your input. So here, if you will see little bit earlier, this one. So whatever this input is there, so output is your green one. So if you will say theta is equal to this one here, so if you will say your theta will be 135 degree, right? If you will move forward, so somewhat here you will find 225 degree, you will find parallel, and moving forward, remember red one is your input, so red one is going forward, and again theta is equal to say 315 degree, it's again becoming parallel, right? Hence moving on. So let us see it from the starting. So remember, red one is your input, green one is your output. So you have four eigenvector here, right? Right? You just concentrate on this white one at angle of 45 degree and angle of 225 degree. You see, if you are multiplying minus 1 in 225, it will become the same angle, means the same direction at theta is equal to 45. And if you will multiply in this minus 1, this one 135, it's become 315, right? So these are not independent vector. So this and this is not independent vector, you can say. And these and these are not independent vector. So here you will have two independent vector, like theta is equal to 45 degree and theta is equal to 135 degree. So here it is 2 by 2 matrix, right? You are giving a vector, it is emitting a vector. So there will be a 2 eigenvector, not 4 eigenvector, right? Okay, so this is about the eigenvector. So what about eigenvalues? Okay, let's take again the previous example. So you was having theta equal to 45 and theta equal to 135 degree, right? So you was having two eigenvector at theta is equal to 45, at theta is equal to 135. So let's see again what is the difference at theta is equal to 45 and theta is equal to 135. Let us play again those video and let us see what is the difference. So you see here, when at theta is equal to 45, you see the input vector and the output vector. See, red one is your input and green one yours output. So the input vector and output vector having the same direction, right? Same direction when it is coming equal. Okay. So and when it is going to theta is equal to 135, say here, so when it is going theta is equal to 135, it will have a opposite direction, right? It is having the input vector and output vector having opposite direction. So here the eigenvalue is defined, correct? So when like previous example, if I am taking, so I have given 1 in a vector in a matrix 0 1 1 0, and it came 1 1. So it was theta is equal to 45 degree, right? And if we will give minus 1 and 1 to the matrix 0 1 1 0, it will give you 1 minus 1 at theta is equal to 135 degree. So if we will see, if this is vector A, if this is a vector A, sorry, if this is a matrix A and your output vector is Ax, your output vector is Ax. If you will take theta is equal to 45 degree, I will better it will write in the red. So if you will take first one, theta is equal to 45 degree. So you was having output vector Ax and the output vector x, right? And both are equal, right? If you will take case 2, let's green one, theta is equal to 135 degree. You was having Ax equal to minus of x, right? It was in opposite direction. So here it is clearly, it can be see that in this case lambda is your minus 1, and in this case it is your lambda is equal to 1 plus 1, right? So you see here the what is the meaning of the sign of your eigenvalues. So if having a positive means whatever the vector is coming in the matrix and output the mat and giving a new vector. So whatever the vector coming in the matrix and coming out a new vector, if both direction having a same, like both direction having a same, then your lambda will have a positive one. If both direction having opposite, your lambda will be negative one, right? So this is about eigenvalues. So this is about the positive and negative eigenvalues, right? So so what about the zero? When will be it zero? So if you are giving us some vector, let us see in the pictorial representation. It is not that much important, but let us see if you have a matrix says 0 0 and you are giving a vector 1 0 in it output will be 0 0, means you cannot say the output vector 0 0 it is parallel to vector 0 1 or it is not parallel to 0 1. So you have a 0 1, sorry 1 0, we have taken the example. You have 1 0 and you cannot say this a point is it parallel or not. So what and you can say yes it is parallel, means point it is there, if it is coinciding to it means it is parallel, right? And but the direction you cannot say in which direction, it having all the direction, right? So you can say it is in the same direction. So and you cannot say it is in the opposite, you can also say it is in the same direction, it is in the opposite direction as well. So in this case your lambda will be 0, right? So moving forward, let us see. Okay, so now you have lambda is equal to positive 1, lambda is equal to negative 1, and lambda is equal to 0. Is this story is completed for eigenvalues? Wait, no. One more important thing is pending. Lambda equal to imaginary. Yes, lambda can be imaginary. Okay, so let us see example. First we will see the example and then we will discuss about this lambda imaginary. Okay, so take one rotational matrix. Say you have a rotational matrix, right? So here I will write the rotational matrix cos theta minus sin theta cos theta. Let us more specific. Let us say we are rotating it by theta is equal to 90 degree. So this one will be your 0 minus 1, 1 or 0. More specific, we are saying that theta is equal to 90 degree, right? So you are giving us some vector, say 1 0, and coming out what? Coming out each, it is 0 1. If you will give 1 1, what it come? Minus 1 will give 1 1, it will come. So it is rotating everything by 90 degree, right? See 0 1, so this is your 0, this is your red one is 0 1 vector, and it is going to be output 0 0 1. Sorry, it is input is your 1 0, so red one is your 1 0, output is your 0 1. So here is your output is the green one, it is 0 1. So if you will say 45 degree, let us play it and pause it at 45 degree. So here is somehow 45 degree, red one you are giving a input 45 degree, and your output is somehow minus 1 and 1. Let us see the green one, the output is minus 1 and 1. So let us play this full video and then we will discuss. And you see your red one is input and green one is output, so never it is going to be matched, because you are rotating always whatever you are giving, rotating it towards 90 degree, and you are saying so in this type of case, so your eigenvalue will be your imaginary. So there will be not the real case, it is the imaginary case. So this is full about this eigenvalues. So eigenvalues can be positive, negative, zero means eigenvalue can be real, and imaginary means eigenvalue can be complex, right? So this was full about this sign of these eigenvalues and all those things in 2D. So let us move forward little bit, and let us see in 3D, because your exam may be target for 3D's eigenvalues and eigenvector. So 3D having a similar case as 2D, but somehow it will be different in projection. So I will discuss that projection. So let us see eigenvalues in 3D. So suppose that if you have a, so let us draw a coordinate system. Say you have a x, here you have y, and here you have z, right? And this one is your plane. Let us take any vector out of the plane. So here is v vector that is out of the plane. So now we are projecting this vector p. So now we are projecting this vector b to the plane. So what will be the projection? So suppose that this is your projection. So how you will project it? Say by a multiplication through a matrix. So how you will project it? By multiplying to a matrix. So you have a matrix, say as projection matrix, and you are giving a b. So you are finding a projection matrix and b, right? So is this will be a parallel in any case? Because our aim is to find eigenvector, and we know eigenvector is only possible when the input vector in the matrix and the output vector from the matrix, it should be a parallel. But here, if the vector b is out of the plane, the projection will be never be a parallel. So in that case, you cannot say, means directly you can say the whatever the vector out of the plane, it is not a eigenvector. But wait, let exactly perpendicular. So if suppose that we are taking exactly perpendicular, so I will make it here different color. So suppose that you have a vector, say C, which is directly perpendicular to the plane, right? So now this vector, if you will project on the plane, it it will come as a point. It will come as a point. So in that case, you can say you cannot say, means it's become like 2D case when the matrix was 0 0 0, right? So here are the two cases B and C. So if you are giving C, vector C, in the projection, it is coming 0. So in the first case, there is, so in the first case, it is not any eigenvector. So in the first case, there is no eigenvector out of the plane. While second case says, yes, there is a vector out of the plane. If the vector is perpendicular to the plane, then that vector will be your eigenvector. But the values of eigen, means the value of eigenvalue will be your 0, right? So this is about your eigenvalues and eigenvector, right? Okay, so we are ending this we are ending this video here. So you have saw that concept of eigenvector and eigenvalues. Next class is going to be a very important, how we will find the eigenvalues and eigenvector. So don't miss that. For that, you have to do one thing. You just subscribe our channel, press a bell icon, so that when we are uploading this new video, how to find eigenvalues and eigenvector, you will uh, you will get the notification. One more thing, whatever the graphical representation we have used, that is made by MATLAB. So the MATLAB code, we have just uploaded it, and we have given you link in the description box, so you can directly download those matrix code, and you can change the input matrix. Simply you just change the input matrix, and you will see how the output vector is varying. तो मिलते हैं नेक्स्ट क्लास में, तब तक के लिए बाय बाय, थैंक यू।